Okay, so here is what the video essentially went over. We're going to look at the graphs of sine, cosine. We won't get into secant and cosecant today. We might touch it, but we're definitely going to work with sine and cosine tonight. And you're going to graph sine and cosine functions tonight. Here's the example that I have. What he did is he unraveled the unit circle on his video. He showed what you would get if you would take the points on the unit circle and plot those specific values off of those points. Now we know that the points on the unit circle represent two things. We know that the x value represents the cosine of the angle where that point is located. We know the y value represents the sine value of that angle where that point is located. So when I look at this, then the way this works, first of all, it's going to show one rotation in the unit circle. So you got point P and it's going to travel one rotation. So let me just go ahead and animate P. And what you're going to see here as I animate P, here's P traveling the unit circle, and it's just going to show P just represents the distance on the x-axis. So that angle, so for example, there's 180 or pi. Here's 3 pi over 2 or 270. Here's 2 pi or 360, and then it starts over again. So P, beginning at the point 10 and travels counterclockwise around the unit circle. P is just the distance that angle's traveling. So that's all P represents. So, and I've got these distances on the x-axis. Now, when I graph sine, and that's what we're going to do now. He did cosine. We can do cosine in a second. When I graph sine, you're going to notice that the x value is still going to be the distance that the angle travels the arc. Okay, so for example, right now it's traveled 3 pi over 2. And then in a moment it will have traveled 3 pi over 2. The x value is the distance traveled on that arc. That's the angle in radians. Okay? The y value is going to be the y coordinate of this point P. Now what does the y coordinate of point P represent on the unit circle? What does the y coordinate of point P represent? It represents the sine value. So whatever that sine value is, root 2 over 2, 1/2, root 3 over 2, 1, 0, whatever it is, okay, at that particular angle. So we're going to plot out what this would look like is if x is the angle measurement and y is the sine values found on the unit circle at point P, which is the y value. Okay, so here's what it would look like. So in blue, you'll see the sine graph. So at pi, we know that at pi, sine is 0. We know that when we get to 3 pi over 2, sine is -1. We know that when we get to 2 pi, sine is 0, and it starts over. The thing that you realize is after you complete one rotation, what's always going to happen? What's going to happen after you complete one rotation? It's going to start over and do the same thing. We know that once we get past one rotation, which is what's going to make this what we refer to as a periodic function. Okay, we're going to talk about sine and cosine being what we call periodic functions. All right, so I can see watching this, follow this along, that it's just plotting out. All this stuff in blue here is the y value found on the unit circle at that particular angle measurement. Okay, so let me do it for cosine because then sometimes it clicks. Cosine, it'll be kind of the same thing. I'll reset it. Show cosine, animate point P. Here we go. Cosine's in green. The angle is in red, so it's just showing you, okay, at pi, we're going to have a cosine value of -1 at 3 pi over 2. Now the difference is here, the coordinates for your cosine graph is still, the x value is still going to be the distance traveled on that arc, so that's still going to be the angle measurement in radians, but the y value now for your point on the cosine graph is actually the x coordinate off of the unit circle, because what does the x coordinate on the unit circle represent? That's your cosine. You're graphing the cosine values. And we're plotting the cosine values as y coordinates. The x values is the angles. The cosine values are the y coordinates for the points that we're plotting in this graph. Okay? So we can see that. Any questions? Now, we're going to go over that, all the aspects of this graph, and I'm going to tell you, you're going to have a little bit of brain overload today because there's a lot. Okay? And it's not going to stop for the next couple days. I about fit as much as I could fit last hour, and I could tell the steam was coming out. All right, so let's go ahead and do that. So go ahead and take out your notes, and we are going to graph sine and cosine. So we'll just start with some generic stuff first. Okay. You're going to have to take really good notes because all this stuff you have to memorize. And guess what? We're adding 6 trig functions, so guess how many more common graphs you got to know? Well, 6 more. Well, 6. It's just 6. Okay, so 6 more common graphs. So we're going to start with sine and cosine today, and that's probably all we'll get through. So sine and cosine. Or cosine. Now, before I get started, I'm going to go ahead and generically, because a lot of things we got to talk about, all the rules for our transformations apply. Everything I taught you a few weeks ago about vertical stretch and shrink, horizontal stretch and shrink, flipping the graphs, shifting them left and right, and shifting up and down are going to apply here. So the good news is you're not going to have to relearn any of that. If you learned it the first time, it's going to work now. Now we call some of it a little bit differently. So like with the vertical stretch, it's going to be related to what we call amplitude. The horizontal stretching and shrinking is going to be related to something we call period. The horizontal shifting is going to be related to something we call phase shift. The only one that kind of stays the same as vertical shifting is still vertical shifting. But the other stuff. Then we're going to have to also keep up with domain and range. And then when we get past sine and cosine, the other 4 all have asymptotes. So we're going to have to keep up with what I call, you have to memorize and learn how to write the equations for the asymptotes. And the crazy thing is they change all the time because you're going to be shifting the graph left, right, up, and down. And it's going to be very beneficial because this will help you. When you get a really good insight into how the graph works, it's going to be really helpful when we start solving equations next week because that's the last thing we're going to do. We're going to do equations and inverse trig. And then that'll be the last stuff we do before we start calc. Okay, so we're doing graphs this week. And then the next 2 weeks, or the last 2 weeks of the try, because we got 3 weeks left, 2 and 3/4 or whatever it is. Yeah, 13 days. So we got 2 weeks. This will be the graph week. Next week will be the equations and inverse and last identities that I covered. Because there's 2 more identities. We got to do double angle identities and half angle identities. All right. So here we go. Write this down. So we got y equals. I'm just going to write down generically what a transformation looks with the trig function. So we got a times, we'll call it trig, little triggy. Okay. You ever seen the music video My Jeans? Remember Little Triggy? Y'all remember Friday? It's Friday.
Oh my gosh.
Okay, there was another one that came out called My Jeans. Well, have you seen it? I know you've seen it. Eric's probably showing it to you. Oh yeah, Little Triggy's in there rapping. I might have to show you all one day just because it's flipping hilarious. All right, this is going to be a b times x plus or minus c plus or minus d. Now I write it as trig, but technically this is how we should write it. Let me show you what it mathematically should look like. This could be any trig function. This is going to be whatever trig function you have, sine, cosine, tangent. All right? Mathematically, it probably looks like this. Y equals a times f bracket b times x plus or minus c plus or minus d. Now let's talk about this. What did A do? What did A do? That vertically stretched and shrinked.
Is the bracket ever closed?
Oh yeah, I gotta close the bracket. Don't forget to close the door. Don't leave the door open. There might be a draft. Okay? Alright? So what does A do? Wonder if they can pick up on my video that I'm gonna be eating soup. Y'all never had this soup?
Well, you just said in the video that
It's so, no, like if they can hear me eating. Not that they can swap.
Yeah, they can do that.
Alright, what does A do? Joe is just like so focused right now, and it's not on math. What does A do? Go class. What does A do? I'm a good teacher, apparently. What does A do? What happened when you multiplied a function by A? Huh? Vertically stretches or shrinks. Very good. So if I put a 2 out here, it's going to stretch it by a factor of 2. If I put a half out there, it's going to shrink it by a factor of 1/2. All right? What does B do? Horizontally stretch or shrink. But that is going to be the opposite of what you think it should do. Like when you multiply the whole function by a number, it's going to do what you think it should do. Like you multiply by 2, you're going to say, oh, the y's are going to stretch by 2. If you multiply by half, the y's are going to shrink by half. This is not going to do what you think it does. Remember I said that horizontal stretching and shrinking does the reciprocal. So if I multiply by 2 in here, it doesn't stretch it. It what? shrinks it by 2. So you're going to have to divide by 2. You're going to have to do the reciprocal, which will make total sense in here in a second when I do period. That's going to, right when I threw the period up there last hour, I didn't explain this, and they're like, why are you dividing by b? And I want you to see. Which brings me to C. Okay, because I'm going to do all of them. You've got to be able to do this for all of them. Works the same for all 6. So B is going to be stretching and shrink. So if I put 1/2 in for B, it's actually going to stretch it by 2. So you have to multiply by reciprocal of 1/2, which is 2. Plus or minus C is going to do what? Left and right. And plus C still does what? Left, and minus C does what? Right? Plus or minus D? Up or down. Okay, up or down. Now, when we start graphing the trig functions, are we ready? Good? When we start graphing the trig functions, we call these different things. So the first thing we're going to talk about today is vertical stretching and shrinking and how that affects the graph. It affects something on the graph, and it's called amplitude. Now, I know that some of you have physics, and you have all kinds of physics terms like wavelength and the trough and whatever, and I don't really care. It's great. Some of these terms cross over into your physics class. Some of them don't. And they're not going to cross over the same way. I mean, exactly. I mean, they mean the same things, but the things we're going to talk about are very mathematical. The things that we're talking about, the physicist is not always interested in. Okay, they are and they aren't. They're going to use some of the stuff that we do to get something else. Like they'll measure the trough, which is from the peak to the peak or something like that, isn't it? Okay, you guys. Okay, so you'll get to it. Wavelength and frequency we do because we do period. Period is frequency is just a reciprocal of period. But amplitude. Here's amplitude. You ready? It's max minus min divided by 2. Now the amplitude is a distance. It's the distance of the max minus the min divided by 2. Now if you think about that, think about it on a graph. You have a max value, Thomas. You have a min value. And I take that difference between the max and the min. I know how far it is from the top to bottom, right? What happens when you cut it in half? If I take the top minus the bottom and you cut it in half, what did you just get? You got the middle. You got the midpoint. The amplitude is simply going to be the measurement. It's the distance measured from the middle to the peak or the valley. It's how far it is from the middle to the top or the bottom. It doesn't matter because you're going to be right in the middle. So the amplitude is the distance from the middle to the top or the middle to the bottom. All right, because you're going max minus min divided by 2. That's kind of a duh thing. It's like geometry. Take 2 things, subtract them, cut it in half to get the midpoint. Okay, that was midpoint formula from geometry. All right, so max minus min divided by 2. I would write it down. Just say the distance from the middle to the peak or valley. Okay? The distance, if you want a definition, if you need to write that down, that would help you, then just put it's the distance from the middle to the peak or valley. Now, here's how you calculate it off the graph. What do you think would affect amplitude? You have 4 parameters in your trig function. Everybody listen. I'll let everybody finish writing. Amplitude, distance from the middle to the peak or valley. Everybody good? Okay. You're going to answer that in a second. Hold on. I'll let you do it in a second. We have 4 parameters. Parameters are like knobs on a stereo that you can tweak. How many of you have a car stereo and it has treble and bass? Okay, I know Joe's all about that bass, all about bass. Okay, all right. So no treble, right? All right. So you have knobs that you tweak, or if you get a flat screen TV, the first thing you go tweak, you want widescreen, or you want 4:3 ratio, or do you want movie style, or cinema style, or gaming style? You can tweak those knobs. We have those knobs. Okay. And so it's like your iPhone settings. You can tweak your iPhone settings, what kind of background you want. We have those settings here. What are the settings that we can change in the trig graph? We can change the trig function, but once we decide on the trig function, x and y are our variables. What are the things that we can change to make this graph look differently? A, B, C, and D, right? Which one's going to affect the amplitude? If it's top minus bottom divided by 2. A. Some people think this does. That doesn't do that. Okay, that just shifts it up or down. The amplitude's the amplitude. Regardless if I shift it up or down, the distance from the middle to the peak or valley is going to be related to vertical stretching. So here's how you calculate amplitude. It's really easy. Since it's a distance, we don't want it to ever be negative, so the amplitude is the absolute value of A. People are like, why is it just A? Because the standard sine and cosine graph without a shift is measured from the x-axis. And what is the x-axis? 0. So that's why it's just A. So you're going to go up A or down A? Up A or down A for your amplitude, which is middle to a peak or a valley. Okay? And you'll see how it works. Amplitude's like the easiest thing to do. The next thing we need to discuss is what's referred to as period. Now, period, when you think about it in mathematics, it's just the amount of time it takes to repeat something. Like you have 6 periods a day. Okay? There's 6 classes. Is it 6 you guys take? Okay, 6 classes you guys take. I keep thinking we're on 5. 6 classes a day that you guys take. All right? 5 for Billy. For something to repeat, it has to be what you refer to as cyclic or an iteration, and what that means is that you have a pattern that keeps doing the same thing over and over and over again. Okay? And once I can find that pattern, I can determine what the period is. Now, when we talk about period, there's 2 ways to think about it. Because I can say that Heidi's birthday is periodic. Okay? Every 300, if today is her birthday, it's not, but if it was, it'd be really crazy. If today was her birthday, you with me? If today was her birthday, 5 years from now, it's going to be your birthday again. Would you agree? That's period. Every 5 years, it's going to repeat. 10 years from now, it's going to be your birthday. Every 10 years, it's going to what? Repeat until it gets past probably 100. And then I'm not going to repeat anymore. Sorry. Me neither. None of us probably. 20 years from now, will it repeat? But what is the shortest amount of time that it would take for her birthday to repeat?
1 year.
1 year. That's what you would call the fundamental period. So the period is the distance. So we're going to define it mathematically. It's the distance. It's the measured distance that it takes for a function to repeat. And it's going to be measured along the x-axis. So it's how far, it's the distance necessary to repeat. How far do you think sine and cosine, how long do you think it's going to take for sine and cosine to repeat? How do you know? Because that's what it is on the unit circle. On the unit circle, it took us 2 pi radians. It took 1 complete revolution. We were going to hit, like right here, you were like, okay, I hit sine as 1/2. Not repeating yet. I hit sine as 1. You know, sine was 0, and then, you know, then it was 1/2. Then it was root 2 over 2. Then it was root 3 over 2. Then it was 1. And then it was like root 3 over 2 again. So still not repeating. It's kind of repeating. I think maybe it is repeating. Maybe not. So you're like root 3 over 2. Oh, I hit root 3 over 2 once. Maybe it is repeating. And then you go to root 2 over 2. Then you go to 1/2. And then you go to 0. And you're like, sweet. I think it may have repeated. But then you go to what? Negative. So you're like, oh, dang it. It didn't repeat. It's not done. It's not until it completes 2 pi radians that it what? It's going to take 2 pi radians for it to repeat. So the fundamental period for sine and cosine is going to be 2 pi. Now, if that is the fundamental period for sine and cosine, what do you think is going to affect the period? If it's the distance necessary for it to repeat. If period is just simply the distance necessary for it to repeat, or the amount of time it takes to complete 1 cycle, for it to be cyclic, for it to repeat over and over again, what in there is going to affect the period? A, B, C, or D? Period. So sine and cosine go like this. The sine graph went like this. Boom. It was a 2 pi. What's going to affect the amount of time it's going to take for it to repeat? B. Why? Horizontally. Because I can stretch it out, make it take longer. I can make that distance it needs to travel a lot longer. Or I can make that distance what? Short. So if I make that distance short, or if I make it really long, I'm stretching and shrinking it what? Horizontally. That's why when you get into physics, this is going to be so popular in physics, because you get into a lot of things that repeat in physics, and they use harmonic motion. If you've talked about simple harmonic motion in physics, have you guys talked about that? Yeah. When you get into that, have you? Last year you did? So if you talk about simple harmonic motion, anything that repeats, the most common mathematical function to represent something that repeats is the sine function. That's why you'll study sinusoidal graphs in physics. When you get into physics, you'll study sinusoidal functions. Because sine is probably the most popular one. Cosine you can use too, but it's just a 90-degree shift. You'll see that in a minute. All right, so period. Here's what it is. If the fundamental period for sine and cosine is 2 pi, how is B going to affect it? Well, you would think multiply by b, right? But remember, x is opposite, so you're not going to multiply by b. You're going to do what? How can I force the reciprocal? Divide by it. And since it's a distance, it's got to be the absolute value of b. Now, that'll make sense in a minute. Like, you might be like, I kind of get it. It's okay if you don't fully get it yet. You will get it in a minute. You'll be like, oh, yeah, that makes sense. Think about it. If b is 2, you would say, if b is 2, what I told you guys is that when b was bigger than 1, it actually shrinks it horizontally. So if it's a 2, how can I shrink it by 2? I need to divide by 2. If it's a 1/2, I said if it was between 0 and 1, I said it stretched it. So if it's a 1/2, how can I make it stretch by 2 and not 1/2? Well, if you divide by half, what does that really force it to do? Multiply reciprocal, and it makes it 4 pi.
So why isn't the formula written differently?
What do you mean why isn't it written differently?
Well, like, why don't you just put x plus minus c divided by b instead of having b on the side?
Because
So that seems-
why do I write x plus c and it goes left? It's just the way x works. It's a natural phenomenon that x works the opposite of what you think it should. That's a good question, because I remember when I was in high school, I was like, why is it x minus c goes to right? Why not just put x plus c? Because x plus c goes to left.
That's silly.
And when b is bigger than 1, why not write it as divided by b? Because if I do that, then it's gonna do the opposite of what I think. X just does the opposite naturally. It's mathematically just how it works out. It has nothing to do with the way somebody wrote it. It has everything to do with what they saw. Okay, this is what they observed. All right, so amplitude period. A couple other things. These are real quick. Phase shift. Phase shift is what we would refer to as horizontal shifting. We call it phase shifting. We do not call it horizontal shifting, and that's just a term thing. It's not a big deal. I don't think anybody's going to stress out about that. It's just learn a new term. The good news is vertical shifting is still vertical shifting, so I'm not going to write that one down. Okay? Are you ready for me to graph? All right, I really need to split this video into 2 videos because I think it'll upload as well. So let me hit stop. Go ahead and give yourself some room and write down y equals sine x. And now this is where it gets overload.